Analysis of electricity consumption at homes using Cambridge clustering algorithm. 현웅첸, 나움, 모하머드 페시케르시, and 동률신. Sungwon University, South Korea. Abstract. Machine learning is a modern field that has emerged as a new tool for data analytics in the distributed computing environment. There are several aspects at which machine learning has improved the processing capacity along with the effectiveness of analysis. In this paper, the electricity usage of home is analyzed through Cambridge clustering algorithm for obtaining the optimal home usage electricity data points. The Davis burden index and serial score find the detailed optimal number of clusters in the Cambridge algorithm and present the pre-application scenario of the machine learning clustering analytics. Keywords: Cambridge clustering, machine learning, unsupervised learning, Davis burden index. Introduction. Machine learning is a subject project of artificial intelligence that is used to develop algorithms and techniques for enabling the computers to run. Reference 1. It is used to the computer for various aspects such as distinguish whether email received are spam or not. Second, data classification algorithm. Third, association rule identification. And fourth, character recognition. Machine learning includes a series of processes in which a computer looks up for similar patterns, generate a novel classification systems, data analytics, and producing meaningful results. It is a kind of artificial intelligence that can be predicted based on the result. If it is supported only by analytics algorithms, machine learning is a step-by-step evolution process that leads from big data analytics to predict future actions toward making decisions on its own through pass-around the result. The key issues for processing a successful prediction model remains to be within increasing the probability and reducing the error, and the said problems are resolved through enabling numerous iterative learnings. At the heart of machine learning are representation and generalization, where expression is an evaluation of data and generalized is processing of future data. Unsupervised learning is a type of machine learning that is used preliminarily to determine how data is organized. Unlike the supervised learning or reinforced learning, this method does not give a target value for input values. Number 3. Autonomous learning is closely related to the density estimation of statistics. This autonomous learning can summarize and describe the main characteristics of the data. An example of autonomous learning is clustering. In this paper, we use Cambridge algorithms to measure the optimal number of clusters based on the Clarence-Calabrese index and the serial score, Davis burden index, and then apply it to household electricity consumption analysis. Previous was machine learning. Machine learning is like data mining, but it is different in predicting data based on learned attribute, main through training data in addition to the three techniques: unsupervised learning, supervised learning, or reinforcement learning. Various types of machine learning techniques, such as semi-supervised learning and deep learning algorithms, are developed has been used. Second, clustering. Clustering is a method of data mining by defining a cluster of data considering the characteristics of given data and finding a representative point that can represent the data groups. A cluster is a group of data with similar characteristics. If the characteristics of the data are different, they must belong to different clusters. It is the main task of exploratory data mining, and a common techniques for statistical data analysis used in many fields, including pattern recognition, information retrieval, machine learning, and computer graphics. Number 3. Maximizing inter-cluster variance, minimizing the inner cluster variance. Note: however, the cluster should be distinguished from classification. Clustering is unsupervised learning without correct answers. In other words, we group similar objects with the group information of each object. Classification, on the other hand, is supervised learning. When you carry out classification task, you will learn to predict the dependent variables with the independent variables x of the data. Number 4. Reference number 4. Third, community feasibility assessment. Since clustering tasks are not correct, they cannot be evaluated as indicators, such as simple accuracy. As in a typical machine learning algorithm, as you can see in the example below, it is easy to find the optimal number of clusters without the correct answers. Cluster analysis itself not one specific algorithm, but the general task to be solved. It can be achieved by various algorithms that differ significantly in their understanding of what constitutes a cluster and how to efficiently find them. Popular notions of clusters include groups with small distances between cluster members, dense areas of data spaces. Scikit-learn, in general, a learning problem considers a set of n samples of data and then tries to predict the properties of known data. If each sample is more than a single number and, for instance, a multi-dimensional entry, it is said to have several attributes or features. Supervised learning, in each data comes with additional attributes that we want to predict the problems can be either classification, sample belongs to two or more classes and we want to run from already labeled data how to predict the classes of unlabeled data. An example of classification problem would be handwritten digit recognitions, in which the aim is to assign each input vector to one of finite numbers of discrete categories. Another way to think of classification is as a discrete form of supervised learning where one has a limited number of categories and for each of n samples provided, one if to try to label them with the correct category or classes. Scikit-learn is a machine learning platform in the middle range of superficial broad Python module. This package high-level languages can easily high-level documentations and proper API suggested. Using BSD license as academic or commercially used. Source code documentation is downloaded from the website. Reference number 10. Supervised learning on supervised learning is many problems is inserted in scikit-learn. Generalized models, linear and quadratic discriminant analysis, kernel rigid regression, support vector machines, stochastic gradient descent models solutions also inserted in the scikit-learn. Proposed approach. K-means algorithm is one of the clustering methods for divided. Divided is giving the data among the many partitions. For example, receive data object n, divided data is input data divided k data. Each group consisting of cluster. Below equation is the K-means algorithms when cluster consists of algorithms using cost function used. Number 11. In other words, one of the data object divided by the k group. Quantity divided similarity. The similarity with reducing the cost function about it, and from the theory each object similarity increases. Different group similarity will increases. Number 12. K-means algorithm in each centroid and each group's data object times summations. From this function result the data object group updated clustering progress. Reference 5. How to be where to be clustering inner way is Clarence-Caravage index, Davis-Borden index, Dunn index, serial score. In this paper, evaluate via Clarence-Caravage index and serial score evaluated. From the cluster, Clarence-Caravage index is the clusters the clusters distributed average and cluster distributed ratio will give it to you. For BK, SK, TR, BK, K minus and N minus K. For this BK is the distributed matrix from the each group. WK is the cluster distributed defined. N is the number of data. CQ is the data group in CQ. CQ is the cluster Q centroid. C is the E of the centroid. NQ is the number of data's number in cluster Q. Serial score is the easy way to in data I each data cluster in data's definition, and I each data is a cluster inner and data's definition BI serial score. SI is equal to calculate that. SI equal max AI BI minus per BI minus AI. From this calculate, SI is equal to that function. SI is close to 1 is the data I each data I is a correct cluster to each thing. Close to -1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library scikit-learn in the household power consumptions clustering. Number 7. Household power consumption from the dataset download from the University of California Irvine Machine Learning Dataset Repository. Number 8. And then use it. This dataset via delimiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and global reactive power x, y axis is experimented. Python library is Anaconda 3 K-means algorithms. Key point is using data K clusters, reduce clusters distance. K-means algorithms input data put the labels. Figure 1 is a before check. Current scalable index and serial score execute. K-means clustering K-means algorithms result. Figure 1 to figure 11 are K-means clustering result for household power consumption from UC Irvine repository. Figure 1 clustering result at k equal 1. Figure 2 clustering result at k equal 2. After all, reduce each cluster's distance, calculate each cluster's current scalable index. In increasing clusters, the current scalable index will decrease with k ratio is to low. Estimate k. This cluster partition will one more or not. Electric consumption rate is very important. This one is the most important fact. Equal with current scalable index estimation. Calculate serial score. The cluster will increases, serial score will decreases with k distributed. A low factor with optimal k represented. From K-means algorithms, calculate proper cluster thing is very important. From the data estimate serial score, the result is k equals 7. Each cluster, centroid, and data prices. Serial score is 0.799 is the optimal score. From the former current scalable index, result are 560.3999 is the optimal result. Using this K-means algorithms, the fact is figure 11. From K-means algorithm cluster 7, each gross centroid and each centroid distance will be optimal value. From this result, each centroid can divide it. Household power consumption rate via clustering. Davis burden index. If the ground truth labels are not known, the Davis burden index scikit-learn matrix Davis burden. The 0 is the lowest score of possible. Score values closer to 0 indicate a better partition. But the problem is this algorithm do not attach it in the scikit-learn library and only explain it in the document page, but cannot explain it easily. Conclusions. From this paper, household power consumption via K-means clustering use a library which is scikit-learn. Anaconda 3 open source personally can easily follow it, and because using BSD license to real worlds don't have difficulties to do that. Not only the K-means algorithms, PCA algorithms, but also SVM algorithms, etc. Other machine learning algorithms cluster can also do it. From this result in real life household power consumptions, diverse analytics, and electricity transmission power management period can estimate it. And each data using electricity consumption, it can be used for progressive taxation, regional to regional demand forecasting. Maintenance of the power plant and the facilities can do it. In the gas company can estimate via K-means algorithms and also can estimate about the gas consumption rate to via K-means clustering and index.